Welcome to this lecture on hybrid blockchains, where we unpack how public and private networks can work together. Think of hybrid systems as combining the open security of public chains with the controlled privacy of private consortia linked by cross-chain bridges. Over the next slides, we'll explore architectures, consensus designs, real-world use cases, and practical steps to deploy these systems securely and compliantly. This slide explains selective data exposure and performance trade-offs in hybrid designs. The core idea is to keep sensitive records on a permissioned ledger while anchoring proofs to a public network, merging high-speed private consensus with immutable public checkpoints. The result is customizable transparency, scalable performance, and the ability to satisfy regulators without revealing secrets, as the graphics illustrate. Here we walk through a typical hybrid architecture shown on the diagram. Private subnets handle confidential transactions, role-based nodes, and private contract execution, while periodic hash batches and trimmed state routes are broadcast to a public chain. That public anchor provides global verification and an auditable checkpoint without exposing payloads, giving organizations an auditable link to the public ledger while preserving privacy. This slide breaks down consensus and finality across layers. The private segment uses known validators and efficient Byzantine or Raft-style variants for millisecond finality. Cross-layer relays enforce that only verified data reaches permissioned realms, and the public layer strengthens security with decentralized consensus like PoS or POW. Together, these mechanisms balance fast settlement, hardened security, and consistent relays between domains. The transaction flow diagram shows how a private transaction becomes anchored publicly without leaking sensitive data. A user submits a private TX, the network orders and executes it, and encrypted results generate a Merkle route. A bridge contract posts that route and periodic checkpoints to the public chain, achieving consensus, while external auditors can verify inclusion without ever seeing plaintext records. This comparative slide contrasts a private network like XDC or Quorum with a public chain such as Ethereum and highlights hybrid benefits. Private lanes secure commercial secrets and speed up cycles, while public anchors satisfy global financiers and immutable proof needs. By combining both, organizations can reduce settlement times, meet regulatory audit trails, and preserve secure, immutable records for compliance. The IBM Food Trust case study illustrates farm-to-shelf provenance using a hybrid model. Permissioned channels capture growers, shippers, and retailer events, while competitive logistics data stays private, and select attributes are anchored to a public hyperledger fabric for organic certification and consumer verification. The visualization shows how anchoring builds brand trust without exposing sensitive supply chain details. This healthcare case study shows HIPAA grade sharing using hybrid blockchains. Hospitals keep encrypted patient records in a private consortium, while interoperable smart contracts anchor consent hashes and anonymize datasets to a public network for research. The system enables automated consent revocation, preserves privacy, and supports verifiable open scientific accountability without releasing identifiable patient data. Managing hybrid systems means addressing operational exposure and technical complexity. Challenges include dual code bases, key hierarchies, and synchronized state that can lead to configuration, drift, or nonce collisions. Practical mitigations shown here are modular SDKs, versioned APIs, parallel testnets, and formal verification of bridge contracts to enforce identical transaction logic and streamline DevOps pipelines. Regulatory reconciliation tackles the tension between immutable ledgers and laws like GDPR or HIPAA. The strategic approaches shown include storing sensitive data off-chain with on-chain hash proofs, tokenizing consent as dynamic NFTs for granular control, and configurable pruning policies that automate deletion after retention periods while retaining auditable proof material for sectoral reporting. Emerging interoperability and ZK rollups accelerate adoption by enabling native cross-chain communication and private, efficient scaling. Protocols like IBC, Polkadot, XCM, and Layer 0 support hybrid topologies, while ZK rollups hide transaction graphs and produce succinct proofs to cut costs. These techniques make hybrid architectures practical for finance, energy, and digital identity by improving privacy and lowering operational expense. The implementation roadmap outlines 4 practical phases: classify data to decide what must remain private versus publicly provable, choose a modular stack suited to needs, prototype cross-layer workflows, and validate compliance early, and future-proof systems with upgradable bridge contracts and modular governance. Iterative testing and regulatory alignment are emphasized to ensure longevity and smooth evolution of hybrid deployments.